Going to start our lesson today on identifying quadratic functions, and then we're going to move into characteristics of quadratic functions. All right, the first thing we need to talk about are the objectives that we have for our unit. We are going to identify quadratic functions, determine whether they have a minimum or a maximum. We are going to graph. We're actually going to give the domain and range tomorrow in class. We're going to find zeros and the axis of symmetry and the vertex. So we kind of have a lot of things to do. This is not very difficult, but there is a lot of information on this. All right, these are the ideas that we have to learn about today. A quadratic function is anything squared. A parabola is the way the graph looks. It's like a U-shaped curve. The vertex is the lowest or the highest point. It's called a minimum if it's the lowest point. It's called a maximum if it's the highest point. The zero of the function is where it crosses the x-axis. And the axis of symmetry is the imaginary line that goes down the middle that makes the parabola symmetric. So that's just an overview of what we're going to look at right now. Okay, this is a parabola. It's the function x squared, which is considered to be the parent function. It has to be able to be written in the form y equals ax squared plus bx plus c. Make a note here, a cannot be 0. Okay, in chapter 5, we had linear functions, and we said that if it had common differences, then that meant that it was linear. So this is what it looked like when we had common differences. There was a constant change in all the x values, and there was a constant change in the first differences for the y values. However, if you look at these do not have a common difference for the first differences, but if you do it again, they do have a common difference. If the second difference is common, then it is considered to be a quadratic function. Here's one for you to try. You need to see if all of the x values have a common difference, and they all go up by ones. Look at the y values. If we do this one time, you get 7,117. If we go out a second time, we get negative 606. So this is not common differences for the second difference, so it is not a quadratic function. Example 2, is this quadratic? This is not going to be quadratic because on this particular one, a is equal to 0. When a is 0, this is linear, not quadratic. So this is not quadratic. Whoops, I just wrote on that. Okay, number 3, you have to be able to put it in the form y equals ax squared plus bx plus c. Well, this 10x squared is on the wrong side, but I could add it to the other side. And when I add it to the other side, I get 10x squared plus 9. It's now in the correct form, and since it's in the correct form, we can say that it is a quadratic function. A is 10. There is no b, so b is 0, and c is the number on the end, which is 9. Okay, the graph of these types of function is called a parabola. No, you don't say parabola, you just say parabola. You have to get enough ordered pairs so that they form this smooth curve. All right, let's try this one. We're going to try negative 4x squared. We're going to make a table of values. I'm going to pick these 5 values. You always need to have at least 5 points. So I'm going to take, over here is where I'm going to do my work, negative 4 times negative 2 squared. That gives me positive 4, and negative 4 times 4 is negative 16. Then I have negative 4 times negative 1 squared. Remember, you have to square everybody first. That gives me 1, so this answer is negative 4. When you plug in 0, you get negative 4 times 0 squared, which is 0. If you plug in a 1, it's negative 4 times 1 squared, which is negative 4. If you plug in a 2, it's negative 4 times 2 squared. 2 squared is 4, and 4 times negative 4 is negative 16. So this is the table that I got, and we're going to graph this table now. So what I need to do now is graph the points. Whoops. Okay, so now that I've taken off my work, if I plot all of these points, it makes a parabola. Notice how it starts little at the middle and then it grows wider as it goes down. Now, can you have a guess as to why this parabola is going down? Any ideas? Okay, we'll find that out in just a minute. All right, now, the only difference between the two equations that we have looked at so far is the value of A. And A does determine if the parabola goes up and down. So that last one went down because the 4 was a negative number. So it opens up if it's greater than 0, and it opens down when A is less than 0. That's the number in the front. All right, let's try this one. Do you think this one opens up or down? Well, when you first look at it, you might think that it goes down because it's a minus. However, you do have to rewrite it in the correct form, and when you move the 1/3 to the other side, it becomes a positive 1/3. So we know that A is equal to 1/3, and since 1/3 is greater than 0, it is going to open up. Number 6, we're about halfway through, by the way. This one, I also need to rearrange it into standard form. So here's my standard form. -3 is my A value. Since -3 is less than 0, the parabola is going to open down. Okay, the vertex is the highest point or the lowest point on the parabola. If the vertex opens up, if the parabola opens up, the vertex is the lowest point. That is called the minimum. If it opens down, then the vertex is going to be the highest point, and that's called the maximum. Okay, let's look at these two problems. Number 7, you have 2 problems to try, A and B. We have to identify the vertex. So if we look right here, the vertex is a dot. That is -1, 2, 3, and +2. That looks like it's -3, 2. This point is the lowest point, so it's called a minimum, and the minimum is at the number 2. On B, the vertex is going to be 2, to the right 2, and up 5. The maximum point is 5 because it opens down. Okay, we have done x-intercepts and y-intercepts before. An x-intercept is when the y is 0, and a y-intercept is when the x is 0. So what we're going to call the x-intercept now, we're going to begin calling it the 0 of the function. Number 8, we have to find the zeros. Well, this one's really easy. You just look at it, look there, and you can tell that the x-intercept, or zeros, there are 2 of them. The zeros appear to be -1 and 3. Okay, if you would like to check the work here, if you plug in -1, you can see right here that it gives you a 0, and if you plug in 3, it also gives you a 0. Okay, if it only has 1 0, that means that the 0 is going to be the x-coordinate of the vertex. We're going to look at that in just a moment. Okay, can you find the zeros of this function? You're trying to find out not where it crosses the y-axis now, but where it crosses the x-axis. If you notice, there's nowhere that it crosses the x-axis. So since it doesn't cross, we say that there are no zeros of this function. There is a vertical line that goes right down the middle of your parabola. It's a dotted line. It's called an axis of symmetry because it's symmetrical, which means it's the same on both sides. You can use the zeros that you find to find the axis of symmetry because the axis of symmetry is always right smack dab in the middle. Okay, now you don't have to copy all of this down. I just want to show you this. If you have 1 0 right here, this is the 0. It's also the vertex, and the axis of symmetry goes right down the middle. Do you see how we always do it as a dotted line? The axis of symmetry is written as x equals a number. That makes it a vertical line right through the vertex. Okay, if you have 2 zeros like this problem, then the axis of symmetry is going to occur right in the middle of those 2 zeros. Number 10, we have to find the axis of symmetry by using zeros. Well, A is very easy because it happens at the x-intercept, so the axis of symmetry is going to be x equals -1. Whoops. This went right on the paper again. Okay, on the B problem, we need to find the average of the two zeros so that we know exactly where the axis of symmetry occurs. So this is at 4, this is at 1. What I'm going to do is add 1 and 4, which gives me 5, divided in half, and the axis of symmetry occurs at 2.5. So x equals 2.5. Now, I always want you to remember that for the axis of symmetry, you always have to have the letter x. All right, next problem. If it has no zeros, or if you can't find it from a graph, then you're going to use a formula, and this formula works for all functions. Okay, the formula is x equals negative b over 2a. A is the number in front of the x, A is the number in front of the x squared, B is the number in front of x, and C is the number on the end. It has to be in the correct order for standard form. Okay, number 11, we have to find the axis of symmetry by using the formula. I'm going to take A to be negative 3, B is 10, and C is 9. So I'm going to take the B value, which is 10, so I have to do negative 10 because the formula is negative B over 2A. So that's negative 10 divided by 2 times negative 3. Okay, so here's my formula. I have found a pretty picture for y'all. Here's my formula, and my axis of symmetry is going to be 5/3. Remember, the way you write it is x equals 5 divided by 3. Okay, our last problem, I believe, is finding the vertex of this parabola. Now, I'm not sure exactly what that is, but I can look here, and it's negative 2 and negative 6. So if I take my formula, which is negative b over 2a, and then that gives me negative 8 divided by 2 is negative 4. So my axis of symmetry is going to be x equals negative 4. Now I've got to take that negative 4, plug it back in to the original problem to find out what the y value of the vertex is. Remember, the vertex will always have an x and a y. The axis of symmetry only has an x. Okay, so I'm going to use the function rule, which is the 0.25x squared plus 2x plus 3, and I'm going to substitute x is negative 4. I work that out, I get that the y value is negative 1, so the ordered pair is negative 4, negative 1. And the axis of symmetry will be negative 4. Okay, so now we have to find the vertex of this problem, and we are going to do this in a very simple way of finding the x-coordinate of the vertex. And actually, you're finding the axis of symmetry when you do that. Find out what a and b are. A is negative 3, the number in front of the x squared, and b is, no, it is not 10. Okay, so anyway, I just looked ahead, and they just messed up when they typed this right here. This is supposed to be a 6. Okay. So negative b over 2a, we're going to substitute a is negative 3. So that's negative, the b is 6, and then 2 times a, which is negative 3, and that gives us 1. So x equals 1. Now I have to take that number and plug it back into the original x value here, and then I can find my y value. So let's substitute in using our function rule. And we're going to put 1 in for x. So here's me plugging in 1. So it's 1 squared, which is 1, times negative 3 is negative 3. 6 times 1 is 6, and then minus 7. Okay, so that final answer is going to give me negative 4. So my vertex is going to be the point written as an ordered pair 1 with negative 4. I believe that's the end. I hope y'all have a great evening, and make sure you bring this back tomorrow. Bye.